This was a chemistry question that was given to a group of Year 12 students, and without worrying too much about the chemistry in the question itself, what I'm going to explain is that they were given an amount of 65%. So this 65% was this amount. So this was the percentage amount that was lost to the water, and they were to use that amount to calculate the total amount of energy produced by the Bunsen burner. So they wanted to use this amount, this partial amount, to work out 100% of the energy produced. Now, what was interesting here was the responses of a lot of the students. Some of you may already guess what a lot of them did. Many of them didn't know how to do it, but the majority of them simply worked out 35% of this amount and then added it back on. So they worked out 35% of 41,256.6, and then they just simply added this back onto 41,256.6 joules. Now we know why this is incorrect, but students don't. And the reason why is the majority of students have been taught percentages using formulas. And we know that formulas just don't always work because you constantly have to be applying those formulas in order to remember them. We just simply forget those sorts of methods. If we were to use a formula, this is the general way that we would teach students how to do this. We would say, okay, we want the percentage amount. So if we think about it as percentage of our original amount, that will be our whole. We don't know what that is. Will give us our part amount. In this case, it would be 65 over 100 multiplied by x is going to give us 41,256.6 joules. Then what we do is we solve for x. To solve for x, we would just multiply both sides by 100 first, and we would get 65 times x equals 41,256.6. I'm just going to keep all of the calculations here for a very good reason. Then we would divide this by 65. So dividing both sides by 65. In the end, to work out what our whole amount or our 100% is, we would end up with this kind of process. 41, so our part amount, 256.6, we multiply by 100, and then we divide by 65. That is the process that we would have to follow. But if we don't understand percentages, this won't make sense to us. It's just simply another rule, another formula that we have to follow. So I'm going to show you why this method works and how you can deliver it to students so that if they don't remember the formula, they can actually conceptualize their way through the process to try to figure out what 100% means. It also kind of highlights the reasons why the previous method of just working out 35% of something does not work. To do this, we're going to need a 100 grid. So here, ladies and gentlemen, is my 100 grid. The first thing that I'm going to do is I'm going to shade in 65% of this 100 grid, and then I'm going to define it. This is my 60%. So that's my 65%. We can shade in 35 if we want to. This is going to be my 35%. You can kind of see why simply taking 35% of 65% and then adding it back on won't work, because when we do that, what we're really saying is we're saying that this is actually my 100%. If we take 35% of 65%, it's actually going to be less than this amount here. So it's always going to be less than 100 when we do that. So we know that 65% is going to be 41,256.6 joules. Now Now this part that's shaded red, that's going to be 35%, but we don't really have to worry about that amount because we don't have any information on that yet. We're actually trying to figure out what this 100% is. We're actually trying to figure out that amount. The simplest way of doing this is to figure out what 1% is. I don't know what the whole is, but I can figure out what 100% is because I know what 65% is. So watch this. If I know that 65% is 41,256.6, and I know 65 ones make that up, I can simply divide by 65, and that will give me 1%. Now this is going to be 634.7 joules. This amount, this is what that 1 square out of 100 is going to be. Are we starting to paint a picture? Have a look over there. We know that that's one of the steps in our original method. That's not the final answer though, because how many of these do we have in 100%? We have 100. So what do? We take our 634.7 and we multiply by 100. Now if we multiply by 100, we are going to get an amount of 63,470 joules. That value is going to make up 100%. If you look over here, that's exactly what we did. We have divided by 65 over here, divided by 65, and we have multiplied by 100. But rather than just giving them this process and saying, this is the formula, guys, use it, you can explain it in this way. So the students will automatically get that whole conceptual understanding of what is actually happening within a system of percentages. What is the percentage of a whole amount and what is that whole amount actually equal to? So there you go, conceptual percentages. Highly recommend that 100 grid.